All right, welcome back. I want to get through a couple of things pretty quickly that I think are very relevant for your next milestone. I want to talk about versioning and provenance, which is one of the things that we're asking you to do in milestone 3. And then I want to leave plenty of time for Adam here giving us a guest lecture in hopefully about 20 minutes. So I want to start with just an example. I think we have shown this before. A couple of years ago when the Apple Card was released, this guy who had quite a big following on Twitter, developer guy, complained on Twitter essentially about how this is a completely biased model and the credit rating thing is completely unfair. And this was a drama that unfolded over a while. She spoke to 2 Apple reps, both very nice, conscious people representing an utterly broken and reprehensible system. The first person was like, I don't know why, but I swear we're not discriminating. It's just the algorithm. It's just the algorithm. So imagine you're in that situation, maybe with the pressure of things blowing up on social media. I don't know how much you care about things blowing up on X at this time. I think at the time it had probably a little bit more impact. One of the things you might want to do is figure out what did actually happen here? What did our model predict? So you might want to figure out what was the actual prediction that the model made? What were the inputs used? What version of the model was used to make that prediction? If there was feature engineering involved, which there was probably in this place, what caused the issue? So you probably want to run into debugging things. And the scoring model used is probably also non-trivial. So you may have multiple data sources, multiple models involved that each evolve over time. So if you run this now, do you get the same result as a week ago, right, when they tried? This is the kind of thing that can be really annoying in a lot of systems, especially if you just copy model files over things, if you update things without a lot of discipline. Figuring out in retrospect what happened can be challenging. And that's kind of what we were talking about today. So maybe just very briefly, openly, if we were to ask you about a specific prediction that you made in your movie recommendation system, could you reliably explain what were the inputs? What was the, I mean, input is just a user ID, I guess, for you, so that's easy. Which model made the prediction? I guess you haven't really updated the model in a while. What exactly was used to train that model? Do you still have the data that you trained that model with? Do you remember all the hyperparameters? If this is about a prediction that's a month ago, could you answer those questions? Could you? Do you have that data left still?
No.
Why not? What's?
Initially, we didn't have any method of tracking what version of the model made what prediction, like what was the model endpoint actually doing. We just know what the input and output was, but we don't know anything about what happens in that black box.
Right. Do you log the input and output?
We do. We can tell you a decent amount more. We can tell you more information than just the input and output, but I couldn't tell you the specific machine learning model part. I couldn't tell you anything about that.
Could anybody else?
Yeah, we have like snapshots of the data that we use for each iteration of the model. So it's like, okay, model M2 has used this snapshot data to train. So
you have the training data snapshot. Do you have the old models still? Okay. You have enough disk space? Okay. All right. So this is the kind of thing that we want to answer, and this is the kind of thing that we will very explicitly ask you for the next milestone. You should be able to tell for a specific prediction what model made that prediction, how was that model trained, what data did you train it with. And for that, let's start with versioning. Assuming Well, a lot of training data sets can be pretty big. Yours are probably okay, but you probably also don't want to store many different copies of that data set. So let's go back to the banking example. Let's say we have a table, a database table with all our customers. We tend to add more customers. Sometimes a customer changes their name or their address. So these things change over time, and we might want to be able to go back in time to know what was the data like 5 a.m. yesterday. How can you version data like this? There are a couple of different strategies. How would you approach this right now if you had to implement this from scratch? You could do periodic snapshots, backups essentially, right? Maybe not with the finest granularity, but once a day, once an hour, and keep all those snapshots. If your data is big, that's a lot of disk space. How can you go back when you add timestamps to things?
Suppose my model was trained on timestamp X, and it was trained, the procedures that is training the data a month before X. So I just filtering the data that was added, that was active on that time.
How do you know what data was used at the time?
Suppose they use all of it.
So what you can do is whenever you add data, add a timestamp, right? So that you can see everything that was added before a certain time was there. But what if you change data? Like if somebody changes the address? Okay, all right. So if it's append-only data, it's relatively easy, right? So if you think of append-only data, which I think your recommendations mostly come in one at a time, right? People are watching things one at a time. Append-only, you are sufficient to have an offset, right? You can know at this point I had the first 5,000 lines and then 5,300 lines and so on, right? That's relatively easy to store. What happens if you actually change data? You can make copies of the entire data set. What's a little bit smarter than that? So you can track deltas, essentially, right? Diffs, and track every time you make a change, track that diff. Oh, not great. Do you know a version control system that works like this? How do version control systems track changes to your data, to files? Do you know how Git works internally? So Git stores copies every time you make a change. And then the diff, if you want that, is just internally comparing two files. So if you make lots of small changes to very large files, Git is extremely inefficient. It stores compressed copies, but it does not store deltas. There are other version control systems that have not won the version control system war, like Mercurial, that actually store deltas over time. You start with the initial file, and then it stores a series of deltas. So you can do that you can replay this. And in a way, you can think of this turning a mutable data structure into an append-only data structure. We talked about event sourcing in the past, right? So if you track changes as deltas over time, you have an append-only data structure, and the offset trick works again. There's one more common strategy. Any idea? S3 is versioning things like this. You can essentially keep copies of individual rows of a database. So rather than making a copy of the entire file or deltas of the entire file, you do deltas of a single row. So these are, I think, the common strategies. Store copies of the entire data set. If you make small copies to large files, it's extremely inefficient. Store deltas. If you have small deltas, that can be very efficient, but it may be more expensive to replay. If you have append of individual rows, if those are versioned, you have smaller changes, right? You can version every single row. Say this Excel or Google Docs does the same thing. You can ask what's the history of a single cell. I don't actually know how it's stored internally. And then if you have append-only data, that's very nice because you can just have an index. There are trade-offs, which one, or if you can recreate data from other data that's already versioned deterministically, you don't need to store that. You can just recreate it, right? That's nice too. So there are trade-offs between those versions. Recreation might be expensive. Storing entire copies is easy, but wastes a lot of space, right? So in practice, you kind of want to think about what kind of data do you have? What kind of changes do you have? Like many small changes in big files or append-only data, right? And find a corresponding versioning strategy. But the first thing here is also why Git is so inefficient of storing large files, right? GitHub will complain if you're over 50 megabytes. It will not accept the file. And that's the reason why, right? Because it's really inefficient. You can store it in external sources. And then that's just versioning the files. You want to get to the model and figure out how the model was trained. So you kind of need to version everything that you use to get to the model and the model itself. What can you do to store model versions? Do any of these tricks work? So when you fine-tune a model, you make some changes. Potentially every single parameter in that model changes. So there's often not a very smart way of doing diffs. There are tricks of sometimes you don't care about all the parameter changes, you care only about the big ones, and then you can do a slightly smarter diff, but it's less accurate. So you can do a little bit, but in practice, maybe you can tell me differently, you essentially just can store copies of models. There's very little compression that you can do, very little smarter than entire copies.
File path is the version.
File path is, yeah, version 1, version 2, version 3.
Version complicated long string timestamp.
Sure, right, but any form of just storing copies and then remembering which file this is. And if you use any tools like weights and biases or any of these model tracking, model store things, they are also essentially just storing copies, right? So if you have huge models and you version them, you need a lot of space. And the reproduction trick doesn't usually work because the training is non-deterministic, right? So you're kind of out of luck there. The pipeline instead, the code and the hyperparameter, that you can just, it's just code. So that you can track in Git or something like this, you should just track that, right? And in the end, what you then need to do is connect all the pieces. Like this model was trained with this Git version of the pipeline code with this version of the data set. Does this make sense? So you have data, you have 100 versions of the data, you have a couple of commits to your pipeline code where you change hyperparameters or something like this, and 10 different model versions. Somewhere you need to track that model version 9 was trained with version 10 of the pipeline code with version 95 of the data. So when you're versioning your pipeline, also make sure that you version all of your dependencies. So be aware of what specific version of TensorFlow this was trained with if you want to have any chance of finding this. We just had this fun exercise yesterday of floating version numbers when you installed LiteLM with pip. Right? This is a bad practice for reproducibility because it takes whatever the most current version is and install it. And today, the installation might be different than yesterday. Also has security practices. In Python, people almost always float, but you can pin version numbers where you say, I use this specific version. For reproducibility, that's very useful. What people often do in practice is just put it in a container at that specific version because the log files and pinning in Python is maybe a little bit annoying, but you can pin this and have this all in source code and pin all of your dependencies. You can also do what Google does and vendor everything and just, well, Go does it at least, and copy all your dependencies and put them in your directory. Not sure that's the best idea.
Just have a single monorepo, every piece of source for everything.
Yes.
Always build from source from that one single number.
Yes, do what Google does, if you have Google resources, if you work at Google. Yeah.
very reasonable thing.
So this is what I mentioned earlier. These tools like MLflow, weights and biases, and so on, they can be used to log information for every training run. And as part of this, you can also log, this is a data version that I trained with. This is a version of the pipeline that I've trained with. So this mapping of model version to pipeline version to data version, you can track with these kind of tools. You can also just write it into a log file. It doesn't really matter if you can refactor it, but these are commonly used for this kind of thing, where you, in your logging information, where you have some code in your training run to essentially say, upload the model that we trained and associate this with these numbers that we have in the source code, like the Git version, the data version, and so on. Does this make sense? This is something fairly feasible that you could implement without a lot of effort. There are specialized tools on top of that. DVC is one that is specifically created as a version of Git that's specifically for data science. It's built on top of Git. So you have the code in Git, you have pointers to the data set in Git, and then you can track things together. What this requires is that you have this kind of infrastructure that says what are the scripts to run and what are the inputs and the outputs that these scripts create, and then where are the data sources and files stored, so that it can figure out, oh, it uses this data source, data clean, or requirements txt, and it can figure out, oh, that's stored in Git versus, or that's stored on S3, and use the corresponding version number and track that when you run this. It can be used for experiment tracking too. You'll see this on Friday in the lab. DVC is one option that students liked in the past for tracking this. It requires that you define everything in there and then run it with DVC, but it can be used as a pipeline orchestration tool that tracks versions along the way. There's a nice alternative design that Google pioneered internally, which is essentially if you run everything into an environment and people always forget to track things or are not willing to put this into configuration files, just track what they're running and figure this out based on system logs, essentially. My understanding is everything that you run in Google, you run on their systems, right? You don't run anything locally. So they can track, oh, somebody's executing this script right now, this Python script, and this Python script is reading this file from Google Big File System database A and writing it to this file. And because people always forget to track these things, can we transparently track this in the background and then reconstruct what was read from what, right? So they are tracking all of this in the background, build a big database, and then after the fact, you can figure out, oh, this was read, this thing was produced by reading these files in this version, and so on. So we won't give you access to Google's system to run this kind of thing, but there's a startup building something similar. You see a tool, Roar, on Friday, which is a command line tool. So rather than saying Python train, you say Roar Python train, and then the instrument system runs and tries to do this kind of thing in the background too, uploads it to a system, and then you can look at DAGs and where this thing's trained. You can explore all these tools for your homework too, figure out what you want to use. There are trade-offs in how explicit it is, whether you want to explicitly document it. I think in SageMaker, this works similarly. If you stay in their walled garden, they can track what you trained on, what data sets you tracked on, and so on. Right? This is quite nice. And the last piece that you need to have is whenever you make a prediction, essentially log the model version. Right? So you have somebody made a prediction, so I used model X, or model version X, here's the outcome. And then if you have that data somewhere else, you can track, oh, model X was trained on this data file with this pipeline and so on, and you could use this for debugging. Make sense? So let me skip this and ask you to do a mini breakout. This is effectively what we want you to be able to do in the homework, right? Be able to say for a prediction, what was this trained on? And let's say you're worried about recommending R-rated movies for some reason, somebody complained about your system. I don't know why this would happen, right? You're all very careful not to do that. But let's say somebody complained about this, and you want to know which model was responsible for doing this, which pipeline version, which code. Talk with your neighbors for like 5 minutes of how you would approach this. What would you maybe plan to implement in the homework? What would you look at? You see more tools concretely on Friday and then actually do it, but maybe do some brainstorming just now how you would approach this. Just very quickly. Go for it. All right. I hope you started the discussion. I think you need to figure this out, what you're actually doing in your system. If you haven't finished the discussion, submit whatever you have. Do you have any questions at this point?